Hi friends, welcome to Curie Electronics. This is the second part of VSSC 2019 Technical Assistant Electronics question paper solution. In each part, we are solving 10 questions. So this is the second part, that is question number 11 to 20. So we'll go to the question. Question number 11. What is the sum and carry output, C out of a full adder circuit having A and B as inputs and C as carry input? The question is, full adder, what is the sum equation and what is the carry equation? The answer is option B. Option B. And for simplicity, we will take a half adder circuit. From this, we will understand the logic. Half adder. We will take one half adder. The half adder, we have AB, sum and carry. So 0 0 0 1 1 0 1 1 is a half adder. Sum will be 0, carry will be 0. Sum will be 1, carry will be 0. Here also sum equal to 1, carry equal to 0. Sum equal to 0, carry equal to 1. Now, this one is a sum. So I will implement the sum. Sum equals XOR gate. See, looking at this, you can understand whenever the inputs are different, output equal to 1. So if you give A and B as the inputs, here you will get the sum which is equal to A XOR B. And the carry you will get it as like this. The carry equal to AB. Carry equal to AB. Now, this C input is the third input. We will add one more OR gate, XOR gate. One more XOR gate, and we will take the C input there. See. So for two gates, for a half adder, we will have A XOR B only. But one more input, that is the C input. Whatever is output is coming from this carry. This carry should go to again one more input. So from this, you should remember the half adder. Once you remember half adder logic, you can write the full adder equation. So we will go to the next question. Question number 12. Two voltage sources of open circuit voltage of 10 volt and 12 volt with internal resistances 2 ohm and 3 ohm respectively are connected in parallel with like terminals shorted together. What is the effective open circuit voltage of the combination? I will draw the circuit. The internal resistance of the first source. What is the supply? It's a 10 volt source. Like terminals are shorted. That's what he told. The cost 10 volt. This is 2 ohm. Again, one more parallel branch is there. That is 3 ohms. And this is the 12 ohm resistor. Now we have to find out this voltage. That is the VOC, open circuit voltage, we have to find. That is the question. So V output voltage equal to This is Intelligence theorem. When parallel branches are connected, this is Intelligence theorem. I don't know. I have doubt whether it's Intelligence theorem or I think it's not Intelligence theorem. It's Millman's theorem. It is Millman's theorem. I have already made a video on this Millman's theorem. So please watch that video so that you will get it clearly. Okay. So I will show you. Now V output is given by using Millman's theorem. We can write it as V1 by R1 plus V2 by R2 all divided by 1 by R1 plus 1 by R2. This 1 by R1 can be written as G also, but you remember this form. This is, we are more familiar with this. So V open circuit voltage, open circuit voltage equal to, what is V1? 10 volt. 10 volt divided by R1, 2 ohms plus V2. What is V2? V2 equal to 12 volt. What is R2? That is 3 divided by 1 by 2 plus 1 by 3. I'll write it here. If we simplify it, we'll get 5 by 2 equal 10 by 2 equal to 5. 12 upon 3 equals 4 divided by 6 is the LCM. 3 plus 2, that is 9 divided by 5 upon 6, which equal to 9 multiplied by 6 by 5, that is 9 6 are 54 divided by 5, it comes to 10.8 volt. 10.8 volt. Please watch the video of Miller's theorem. Millman's theorem. Not Miller's theorem, Millman's theorem. But I am having a doubt which theorem, what is the name of theorem? It's Millman's theorem. Okay. So the answer is option D. Question number 13. Question number 13. A train moves past a telegraph post and a 264 meters long bridge in 8 seconds and 20 seconds respectively. What is the speed of the train? That means we have a post here. After that, we have a bridge here. After that, we have a bridge. And let's assume that this is our train is passing. I will draw a train. You have to believe this is a train. Okay. Easy. More than this, I don't know how to draw it. Okay, this is a train. I'll write it train. Train. So train should have one length. What is the length of the train? We will take it as x, because the train will take 8 seconds to pass this post. That means in the front side of the train, then the back tail of the train also should pass. So length of the train equal to x. And here it is taking 8 seconds. 8 seconds. And this timing is how long it takes? It is taking 20 seconds. And he is saying one more thing. The distance of bridge equal to 264 meters. Plus we have to take 64x plus 264x plus x. Why you will take x? Because the train should pass from the train. If this is the bridge, I'm writing it down. This is 264 meters. The train is coming from here. Okay. So train length also we have to consider. So this is train, good train. I like it. You may not like it. Okay. Now, so this train distance is the x. This is, we have to take it as x. Now we will solve it. Now read the question once more. A train moves past a telegraph post and a 264-meter long bridge in 8 seconds and 20 seconds respectively. What is the speed of the train? It is assumed that the speed of the train doesn't change. Okay, so now what is speed? Distance multiplied by time. Now what he has given, to pass the post, it is taking 8 milliseconds, that is x by 8. Distance, what is distance? The speed, distance traveled into time taken, that will give the time. That will give the time. 1 second. Time. Okay, sorry. What is speed? Speed equal to distance by time. How fast or how fast you are covering a distance, that is what the time. So here speed, that is speed. So speed equal to distance by time. To cross the post, the train is taking 8 seconds. So that I have taken as x by 8. Okay. Which can be equated to, because that's constant, the speed of the train is constant in this problem. Okay. So when it passes the post as well as when it passes the bridge, the speed of the train is constant. So I can write x plus 264 divided by 20 equal to, these two are equal to, because speed is equal. Based on speed I am writing this. Now we have to find the x. If you find x, we are getting distance. X we will find out. If I cross multiply, 20x equal to 8x plus 264 multiplied by 8. What is 264 multiplied by 8? 8 4s are 32, 3, 48, 51, 2, 21. So 2. So we will get 12x equals 2112. So from there x equal to 176. 176 meter we got. X is the distance. Now what is speed? We know speed of the train. Speed equal to what? Distance by time. If I take that post, what is my distance? X equal to 176 divided by 8. It comes to 22 meter per second. This I have to convert it to kilometer per hour. If I multiply this by 18 divided by 5, I will get it in kilometer per hour. So 22 multiplied by 18 equals to 396 divided by 5. 396 divided by 5, we will get 79.2 kilometer per hour. So the answer is option D. Question number 14. Which of the following is false for a continuous time signal? Any signal can be expressed as a sum of an odd and an even signal. This is true. Option B, sum of two periodical signals is always periodic. This is wrong. So the question is, which of the following is false for a continuous time signal? Answer option B. Any periodical signal can be expressed as sum of sinusoidal signals. That is correct statement. Okay. This option B, sum of two periodic signal is always periodic. It is not always. Sometimes it comes. When you take two periodic signals and if you take their ratio, if you get a rational number, then it is periodic. Otherwise, it's not periodic. We'll go to the next question. Question number 15. Hi guys. The built-in potential of a PN junction diode is 0.7 volt at room temperature. What will be the approximate value of built-in potential if the doping concentrations on both sides are doubled? Assume ln2 equal to 0.7. Natural log of 2 equal to 0.7. That's what is given. Now, what is the built-in equation for built-in potential? V equal to Vt multiplied by Na Nd divided by Ni square. Ni square. This is the one more taking. Ln is there. Ln is there. Okay, I'll write it once more. No, let me. Okay, I'll write it once more. It is not correct. A built-in potential V equal to V. This is a thermal voltage and natural log of Na Nd divided by Ni square. So he has already given the built-in potential of a PN junction diode is 0.7. Okay, so I am writing it 0.7 equal to V thermal volt. What is thermal voltage? That is the 26 millivolt. Vt equal to 26 millivolt. Vt equal to 26 millivolt. Ln of Na Nd by Ni square. Okay, this I will take it as equation 1. Now what is the question he is telling? What will be the approximate value of built-in potential if the doping concentration on both sides are doubled? Doping concentration means, or double means, instead of Na, he will add 2 times Na. Instead of Nd, he will put 2 times Nd. So I will write it. I will take it as new V dash. That is the new built-in potential. Vt multiplied by Ln. Instead of Na, it is 2 times Na. Instead of Nd, it is 2 times Nd divided by Ni square. Ni square. Now we have to find out what is the new built-in potential. That's V dash. So this we can be written as Vt now. Vt is 26 millivolt multiplied by Ln of what is there? 4 Na Nd divided by Ni square. So V dash equals, how this can be written? This can be written as 26 millivolt Ln of Na Nd logarithm, okay, basic of logarithm Ni square, okay, plus natural log of 4. Natural log of 4 I wrote. I'll write it down. We are solving it here. We want V dash. So V dash equals, guys, are you with me? Please be with me. V dash. So now, see, 26 millivolt Ln Ni square. This term can be replaced. This is what we are having it here in the equation 1. Same. So this can be replaced with 0.7 plus Ln of 4. This can be written as Ln2 square. Okay, which equal to 0.7 plus 2 times ln of 2. ln of 2 he has given here. What is ln of 2? Natural log of 2. If he has not given also, you should remember the value of natural log of 2. 0.7 or 0.693. So which equal to 0.7. One more we have missed out. See here 26 millivolt is here. 26 millivolt, because this 26 millivolt is common for both. Here also 26 millivolt is there. Okay. Multiplied by 26 millivolt plus 26 millivolt multiplied by 2 times ln of 2, which equals 0.7 plus ln of 2 equal to 0.026. I am converting into voltage, plus 2 multiplied by 0.7. What is the value it comes? If we solve this question like this, then only you can solve it without using calculator. 26 multiplied by 0.7. Multiplied by 2 plus 0.7. 0.7364 we will get 0.7364 we will get as answer. So you need to practice it, then only you can solve these questions quickly. Okay, and try to remember the value of what is the natural logarithm value of 2. So we'll go to the next question. So the answer is option B. Question number 16. In the given circuit, D1 and D2 are 5.1 volt and 6.2 volt Zener diodes respectively, with forward voltage of 0.7 volt and near current of 1 milliamps. If V is equal to 5 volt, what will be the output voltage? We have to find out. Now, so D1, okay, now simply based on the virtual ground concept, this point also will be at ground 0 volt. And we are applying 5 volt here. V is equal to what? 5 volt. 5 volt. So what is the current flowing through this 1 kilo ohm resistor? That is V divided by 5 volt. 5 volt divided by 1 kilo ohm resistor. That will give us 5 milliamps. 5 milliamps of current is flowing. So that is understood. This 5 milliamps of current should go to this branch as well as this branch. Okay. Now I will assume, I'm going to assume this diode D2 is forward biased. When it is forward biased, what is the voltage here? 0.7 volt. 0.7 volt. So it is forward biased, and this has got the Zener is working in the breakdown region. So what is the voltage here? 5.1 volt. Correct. D1 equal to 5.1 volt. Zener is in the breakdown region. I am assuming that this diode is forward biased. So Zener also in forward reverse breakdown happened to the Zener. So so here we have a 5.8 volt. 5.8 volt difference we have. 5.8 volt we got. Okay. Now 5.8 volt we got. Whether it is correct or not, we have to verify whatever our assumption is correct or not. If it is 5.8 volt, what is the current through this 2 kilo ohm resistor? That is I through 2 kilo ohm resistor. That is 5.8 divided by 2 kilo ohm. What is the value? It comes to 2.6 milliamps. So 2.6 milliamps flows here. 2.6 milliamps flows here. Out of 5, the remaining 2.4 is flowing in this branch. 2.4 milliamps is flowing in this branch. That means in a series circuit, current is same. So 2.4 milliamps is flowing through this diode D1. Once the current is more than the knee current, the zener is on actually. The zener is on in the breakdown region because our current through the branch is more than 1 milliamps. So our assumption is correct. Now what is the voltage here? V output. Because this is like this point is ground. Okay. This is at ground point. 0.7. So if you measure it, the output, see this area, this will be plus, here it is plus, minus. I'll use a different color. See, now the polarity we have to see. Polarity, any changes that because different polarities are here. Now this diode, this part is plus. We are adding like a battery. This is minus. But here it is plus because here is the reverse breakdown. This is minus. So here we will get negative 5.8 volt. I think this question is really easy for you. Okay. Using the concepts only, we have solved this question. Not much calculations. Okay guys, we'll go to the question number 17. Which of the following is true about transconductance of a MOSFET? What is transconductance? Transconductance, we normally get a curve like this. This will be ID and this will be VGS. We'll get a curve like this. This is the transfer characteristics. This point is the GM naught. Here, what is transconductance? GM, transconductance is equal to change in drain current divided by change in VGS at IDS equal to constant. And we are keeping the IDS constant and varying the variation of ID with respect to variation of VGS. That is what GM. There is one more equation for GM, that is transconductance equal to GM naught. That is the maximum value of transconductance multiplied by square root of ID divided by IDSS. This is the drain saturation current. So based on this equation, what is the question? Which of the following is true about transconductance of a MOSFET? D is the drain current. The drain transconductance is directly proportional to square root of ID. The answer is option B because see drain current equal to directly proportional to the square root of transconductance. Okay, transconductance is directly proportional to the square root of ID. So we'll go to the next question. Question number 18. All are teenage. Which of the following is true about a P MOSFET? I'm not going to explain this question much. Drain current consists of holes in the P MOSFET. Drain current consists of holes flowing from source to drain. This is correct statement. Okay. And because it's a unipolar device, MOSFET is a unipolar device, that is why. And option 2, to turn on an enhanced P MOSFET, gate voltage should be made more positive than source voltage, at least by magnitude of threshold voltage. This is not correct. And the third option, the transconductance is directly proportional to the oxide thickness. It is really true. Transconduct is directly proportional to oxide thickness. Which of the following is true about P MOSFET? So the answer option 1 and 3 are true. Answer option C 1 and 3. The question number 19. Which of the following is false about compensating an operational amplifier? Operational amplifier. Compensation of an operational amplifier. Used to stabilize op-amp in the negative feedback operations. This is true. Okay, why compensation is used in operational amplifier? Used to stabilize the op-amp in negative feedback operations. Establish a dominant pole at low frequency. This is also true. May make use of Miller effect to realize large effective capacitance internally. This is also true. Increase the bandwidth of the operational amplifier. We won't use a compensation technique to increase the bandwidth of the operational amplifier. So this is not right. So the answer is option D. Hello. This is the last question for the part 2. So every part I will take 10 questions. So you will not burden with the full topic. So you also try to learn 10 by 10 by question or 5 by 5 questions. So small steps. So learning at 15 minutes, half an hour, 10 minutes will make a lot of difference. The question. A non-inverting amplifier with gain 10 is realized using an operational amplifier having open loop gain 10 to the power 5. What is the feedback factor beta? And now closed loop gain equal to open loop gain divided by 1 plus beta times open loop gain. Using this equation, we can find the value of beta. Now, what is the closed loop gain? The closed loop gain will be lower value, that is 10 he has given. What is the open loop gain? 10 to the power 5 divided by 1 plus what is the value of beta? Beta we have to find. What is open loop gain? 10 to the power 5. Now we will simplify this. Okay, now if I cross multiply, what comes? 10 plus beta times 10 to the power 6 equals 10 to the power 5. Now we have to find the beta 10 to the power 6 equal to 10 to the power 5 minus 10. Now, correct? Is it correct? I hope so. Now, what I'll do, I will divide. Can I divide this equation? No, I can't. One second. 1 second. Okay, this is correct. Okay, now 10 to the power 5, that is 1, 2, 3, 4, 5 minus 10. What we will get? We will get 1, 2, 3, 4 followed by 0. So beta times 10 to the power 6 equals 1, 2, 3, 4, 5 minus 10. We'll get 4 nines followed by 1 0. 9, 9, 9, 9, 0. Now what is beta? Beta, what happens? 990 divided by 10 to the power 6 comes here. We can take the 10 to the power minus 6 up. Once you take it, what happens? 99990 multiplied by 10 to the power minus 6. It becomes 10 to the power minus 6. But if you see all these answers, there is 10 to the power minus 3 is there. So what you will do? Divide by 1000. Divided by 1000 means, if you do, then we can write it in. So it becomes 99.99 into 10 to the power minus 3. Minus 3. So the answer is option A. 99.99 into 10 to the power 3. I hope this was useful for you. And maybe most probably tomorrow I'll upload the next 10 questions, and within a week I'll complete this question paper, remaining all questions. If any doubt or any mistake, please let me know, or any clarification, I'll be happy to correct it. And one more thing, I'm planning one more 2, 3 lectures on MOSFET. Okay, so guys, thanks for watching. So we have completed first 20 questions of VSSC 2019 question paper for technical assistant. See you guys. Thanks for watching. Thank you.